welcome to episode 123 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes that object so interesting to astronomers. So I will now turn on the random number generator. Fortunately, that backfire from the random number generator did not produce any smoke. The coordinates from the generator for this episode are 13 hours, 33 minutes, 35.8 seconds for ascension, and plus 16 degrees, 49 minutes, 4 seconds declination. This episode's coordinates point to the object QSO 1331 plus 170 in the constellation Coma Berenices. The letters QSO stand for quasi-stellar object, which is another name for a quasar. The digits give the location of the object in an older coordinate system. So a quasar is one of many different types of galaxies with an active galactic nucleus, or AGN. I've talked about AGN a lot. An AGN contains a supermassive black hole, a disk of gas and dust flowing into that black hole, and jets of gas that emerge from the poles of the AGN. I'm just going to keep this description short for this episode, and I really hope that my descriptions of AGN don't get too repetitive in this podcast series. Anyway, quasars are a subset of galaxies with AGN that are very far away and where the jets are kind of pointed towards the Earth so that they aren't really noticeable. When quasars were first discovered in photographic plates in the mid-20th century, they looked like hazy star-like objects, which is why they're called quasi-stellar objects. These days, it doesn't make much sense to think of these things as quasi-stellar, so I recommend not thinking about it too hard, or else you will hurt your brain. QSO 1331 plus 170 was discovered in a survey at radio wavelengths with the Molonglo Observatory in the early 1970s. Initially, it did not necessarily seem that different from any other quasar. Then, shortly after its discovery, people performed spectroscopic observations of it in the visible part of the electromagnetic spectrum. Because the expansion of the universe makes galaxies that are further from our own appear to be moving away faster than galaxies nearby, quasars seem to be moving really fast because they are really far away. Spectroscopic observations usually look for the Doppler shifting of the light emitted from or absorbed by specific atoms and molecules at specific wavelengths to determine how fast these objects are moving away from the Earth. And because those wavelengths of light look like bright or dark lines in spectra, they're usually called spectral lines. QSO 1331 plus 170 was found to be moving so fast from the Earth that the wavelengths of the emitted spectral lines from hot interstellar gas in the galaxy were stretched to 3.09 times their original size. Astronomers like to express this wavelength stretching using a term called Z, or if you're British, Z, where the ratio of the observed wavelength size to the original wavelength size is set equal to 1 plus Z. In other words, Z equals 2.09 for QSO 1331 plus 170. This Z corresponds to a distance where the light from the quasar would take 10.5 billion years to reach the Earth. All of this actually was not unusual for quasars discovered in the 1970s. What was unusual about the spectrum of QSO 1331 plus 170 was that a few different spectral lines associated with atomic hydrogen were detected in absorption in the spectrum of the quasar, and those spectral lines were less redshifted than the quasar itself. In other words, the wavelength at which light was being absorbed was shorter than the wavelength at which light was being emitted from the quasar, which meant that whatever was doing the absorbing appeared to be moving more slowly away from the Earth than the quasar. Moreover, the absorption was really strong, which meant that whatever was doing the absorbing contained a lot of hydrogen gas. The people who discovered this first thought that this cold atomic hydrogen gas was somehow part of the quasar. For example, it could have been in some sort of gas cloud ejected from the quasar towards the Earth at really high velocities, thus making it look like the gas clouds were moving away less slowly than the rest of the quasar itself. However, the real explanation turned out to be that the absorbed light was created by objects that were completely unrelated to the quasar, but that happened to be located between us and the quasar. And just like more redshifted objects, where the wavelengths of light, more stretched out, are also further away, these objects absorbing light at less stretched out wavelengths were closer to the Earth. One of the light-absorbing objects has attracted a lot of interest because of how much light it is absorbing. This object was at a redshift where z equals 1.78, or where the light was stretched out to only 2.78 times its original size, or where the light from the gas took 10.0 billion years to reach the Earth. Because this object contains a lot of atomic hydrogen gas that produces a lot of spectral lines, including a spectral line called Lyman alpha, and because the absorption lines look extremely dark in the spectrum of this absorbing object, it has been called a damped Lyman alpha system. Given how much light this object absorbs, it's probably an entire galaxy sitting between us and the quasar QSO 1331 plus 170. I've actually discussed objects like this before in this podcast series, but I think what makes this specific damped Lyman alpha system so special is that it was discovered very early on in the study of quasars. It wasn't the first such damped Lyman alpha system discovered, but it was close to being one of the first. This damped Lyman alpha system became a really popular object for astronomers to look at in the 1970s and going forward. Astronomers basically wanted to see what other weird stuff they could find in the spectrum. One study managed to rediscover hydrogen gas absorbing light at radio wavelengths. Another found carbon, oxygen, magnesium, aluminum, silicon, and iron in the damped Lyman alpha system. Another found molecular hydrogen, which is a bit different from atomic hydrogen in that it is colder and is also much more likely to form new stars within other galaxies. In the present, astronomers have detected various intergalactic gas clouds and various galaxies absorbing light in front of various other quasars. So the damped Lyman alpha system in front of QSO 1331 plus 170 isn't considered to be as special as it used to be. However, it was still one of the first damped Lyman alpha systems ever discovered, and I think it deserves recognition for its special role in the history of quasar spectroscopic studies. So that wraps up my summary of QSO 1331 plus 170, and the location on the Earth's surface corresponding to the position of this quasar and the damped Lyman alpha system in front of it is about 250 kilometers south-southwest of the southernmost point of the Big Island on Hawaii. This is an area that Polynesian navigators would have sailed through when traveling between Hawaii and various other Polynesian islands to the south, including the Marquesa Islands, Tahiti, and the other Society Islands. While Polynesian navigators had multiple techniques for identifying the location of an island before actually being able to see the island itself, I think that this location might have been too far south of the Big Island for Polynesian navigators to clearly identify where they were. they would probably have been more likely to find the damped Lyman alpha system in front of QSO 1331 plus 170 first. You can find the website for this podcast at www.randomastronomicalobject.com. You can visit the website to read information about the astronomical objects, view images of those astronomical objects, look up additional reference information, and send me random feedback. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy at www.sasha-endy.de, and these sound effects are from the Freesound project at www.freesound.org. Thanks for listening.